So, in this video, I'm going to talk about basically aggregates, functions, and group by. So, I don't know, first off, I'll read in my actual import and the CSV file. We'll have a little look at that data frame. Now, I've actually used scores3.csv, which is a completely new CSV file, and it's basically the old CSV file, except instead of Oscar's age being DE, it's now 23, just so that these default load as integers. Right. Now, what is aggregate? Well, aggregate, I'll show you now, using the group by, is where we group a bunch of data by a column. Right. We might find like a value from that column. I'll just kind of show you. So I'm going to use this group by function on the data frame with the column sex as our column, because we want to know if they're male or female. We're going to get the mean for that. What's the mean? Right? I'll show you. So what this has done, this aggregate function, it's taken the sex column and it's divided it into all the different values in there, which are female and male, F and M. And it's given us the mean for F and M for anything that you can do, maths on. So the ages, because they're all integers, we can get the mean ages for all the women, which is 42.5 or 42.5 years of age. And the mean age for men in this entire CSV file is 48.4. And then we can get the score. So you can see that women on average are scoring higher and men on average are scoring lower. Maybe that's to do with age, maybe it's to do with sex, who actually knows? But basically, we've been able to see an overview of the mathematics, or the means for all of the different sort of integer values that we can get a mean from for these different groups, because we split our column sex into groups. Okay, now we can actually get we can actually sort this. So you can see here that it's sorted by, who's got the highest age or whatever. We can sort it by the score, or we can sort it by the age. I think it's actually sorts by the lowest. I can't remember if it's ascending or descending. I think it is ascending. So we're going to group by the sex here. We're going to say dot mean, and then we're going to say dot sort underscore values. And we're going to sort these values by the score. Let's see what we get there. And you can see that men end up coming first because we're sorting by a score in ascending order, and because the men overall on the mean had a lower score, they appear at the top. So we've grouped by these different groups, i.e. the groups that we've found in sex, and we've got the means for both of these different groups. And we've sorted it by the score, the lowest score first, so score in ascending order. Okay. We don't have to group by just that. We could, for example, we might want to know, if different age groups get higher scores than others, for example. So we might find it more useful to group by age. Okay, so I'm going to do that here. We'll get the mean for that. Just see if we get some new insights from age. And you can see we get all our different ages. 12 and 15 get very low scores. Looks like people who are 32 get a very high score, but it might just be that there's only one person who was 32, for example. We've got some different scores. And we can actually, it makes more sense now to copy and paste this, and it makes more sense to sort it by score at this point. Okay, and then we can see what ages get the highest and lowest scores. So we're going to sort it by score. And now when you look at this, you can see the lowest scores from those who are 67, but it might just be because we've only got one person who's 67 and they scored a 1. It probably is what it is, the highest scores from people 32, and we got it in ascending order, so we can see by the score what age is getting that sort of score. Now if we had 1 million values, these scores wouldn't just be because there's just one value for the age 67. These would be the real means, they'd be proper means, right? Now, mean isn't the only function we can perform on this, so we can actually perform, for example, the sum. So we can say group by, we get sex, and we can group it by the sum, right? Which will give us the sum of all of the sort of integer values. So it'll give us the sum of the score and the sum of the age for both males and females. Should be female first, if I recall correctly. Yep, so we can see here that the total age of all the females is 340, and the total age of all the males is 533. The total score is 46, and the total score is 58 for males. So we wouldn't really need that sum. We don't need to know the overall combined age of all females or all males in our CSV file. We may want to know the overall score, because there might be groups with different overall scores, for example. Like let's imagine there were 10 teams and they all had, and you had the individuals from those team scores, but also the overall group score. That's something that you might want to sum up, but you probably wouldn't want to sum up the score and the age in this case. You just can if you wish to, right? You can also get a count. So you can say sc_df.group by, and we're going to group by age. We'll get a count. Or should we group by? No, we'll group by age and we'll get a count. Okay, so what we get here is a count of all the different entries. So you can see there's a count of how many people are age 12. There's two. There's two names, sexes and scores for people age 12. There's one for people age 15, four for people age 23. You can see that for a lot of these ages, there's just one person, and that's probably why we got such a strange mean here, right? We can also get the counts for other things. So we can get the counts for the name, scdf.group by name. Oops, need to put that in brackets. Now we get to see all of those lovely names, and you'll be able to tell that there's only one. All names are unique. You see that? 11111. All names are unique. This is a good way to check that we don't have duplicates, by the way, because if you've got a large data frame, what you could do is you could run the count, and you could get a list of just one of these, and if the count's more than one, it means you've got duplicates of a name or whatever value. So this is a way you could check for duplicates. There's probably other ways as well. It just gives you a good overview of how much there is. And one more thing you can do is you can group all of these different you can group a couple of columns together. So I can actually group, for example, age and sex. I can get the mean for that, right? And this might show us, for the groups. So we get age 12, we get female 15, right? And now we've got two values. We've got female and male because we've got 4 different ages. And we're getting the mean scores for these ages and these sexes. So we're seeing if females of the age 23 are smarter or get a higher score than males of age 23. And they do. Here, females of age 45 get lower scores than males of age 45. And that's it, because there's no more multiple entries for ages. So that's really it. That's all aggregate functions in the group by really does. It just allows you to group by a certain thing and find out, apply different mathematical aggregate functions to, different sets of groups, right? There's more aggregate functions, I think, than mean, sum, and count, but I'm just using those for now to keep it simple. Thank you for watching and hope you enjoyed.